Today, let's start solving the paper uh, 2021 May June paper 42. Yep, 2021 May June paper 42. A particle, let's start with the first question. A particle of mass 0.6 kg is projected with a speed of 4 meter per second down a line of greatest slope of a smooth plane inclined at angle 10 degrees to the horizontal. Okay, so first let us write all of this. This is this is an inclined plane. The angle is 10 degree. The mass of the particle is 0.6 kg. Okay. So this will be 6 Newton. Why? Because if mass is 0.6 kg, then weight is equal to mass into gravity. So mass is 0.6, gravity is 10, which is 6 Newton. And weight always acts downwards, hence weight is 6 Newton. Is projected with a speed of 4 meter per second. Okay. So the speed will be 4 meter per second. The initial speed will be 4 meter per second. And what they have asked, use an energy method to find the speed of the particle. Okay, energy method. As soon as you read energy method, only one thing should come to your mind. What energy method means is work done by driving force equals delta KE plus delta GPE plus work done against resistance force. So this is what the energy method is. To find the speed of the particle after it has moved 15 meter down the plane. Okay, so let's assume that this is 15 meter. So when the particle reaches here, what will it be? What will the velocity be? That's what we have to find out. So let's start with this. First, what is the work done by driving force? Now, let's first draw all the forces acting on this. So 6 Newton is there. This is a smooth plane. So there will be no frictional force. The only force will be the force due to the weight and the contact force. This will be 6 cos theta, 6 cos 10, and this will be 6 sin 10. These are the forces due to the weight. I just resolved it. This is mg sin theta, and this is mg cos theta. So now that we are done with this, let's go down. Work done by driving force. Work done by driving force will be 0 because as you can see, the question does not mention anywhere that it is being pulled by a force of this Newton. And there is no mention like this. So work done by driving force will be 0. Now delta kinetic energy. Delta Ke equals final Ke minus initial Ke. Now what is the final Ke? The final Ke is half into what is the mass of this particle is 0.6. And what is the kinetic energy here? V square minus the formula for Ke is half mv square. So this is half, this is mass, and this is the velocity square minus initial kinetic energy. What was the initial kinetic energy? The initial kinetic energy will be half into 0.6 into v square. The velocity here was 4. So 4 square. And because this is the smooth plane, there will be no resistance forces. So work done against resistance forces 0. So we are done with KE. We are done with work done by resistance. We are done with driving force. This work done by resistance is 0. What about delta GP? So now, as they have said, the particle is moving down 15 meter. This angle is 10. So what will be the height? Let's find out the height. We can use sine 10 equals h upon 15. And so, therefore, the height will be 15 sine 10 meter. And what is the formula for GP? GP is mgh. So what is the mass of the object? The mass of the object. Now talking about GP. Mass of the object is 0.6, gravity is 10, and height is 15 sine 10. So now we can go ahead and we can simplify. This will become 0.3, then this will become 0.3, 0.6. So therefore 0 is equal to 0.3 v square minus 0.3 into 4 square plus 6 tens are 0.6 into 10 will be 6, and 6 into 15 is 40. 6 into 15, 1 second, let me put that. 6 into 15 is 90. So 90 sine 10. And now let's rearrange to make v the subject. So this will go there. Minus 0.3 is equal to v square minus 1 second. The entire thing will go there. So 0.3 v square will become minus 0.3 v square equals minus 0.3 4 square plus 90 sine 10. Then v square is equal to minus 0.3 4 square plus 90 sine 10 upon minus 0.3. And this, as this minus 3 has gone down, this v square can also go and become root. So the entire root v. So if I put this in the calculator, minus 0.3 bracket 4 square plus 90 sine 10, answer upon minus 0.3. So the answer is v square. Now here there is one thing which we missed. What is GP? GP is mass into gravity into height. And what we are finding here is delta GP, which is the change in GP. So now, if you tell me that there is one object, I'll give you an example that is standing at 50-meter height, and then it goes down to 20-meter. Let's assume the mass of the object is 1 kg. So what is its initial GP? The initial GP will be 1 into 10 into 50, which is 500 joules. And then later its GP will become 1 into 10 into 20, which is 200 joules. So the change in GPE will be 200, which is final minus initial, minus 500, which is minus 300. So as you can see, as the height is decreasing, or as the height is decreasing, as the ball is going down, the change in GPE will become negative because the height is decreasing, right? So here what error we did was we took height as 15 sine 10. This height is 15 sine 10. But if the ball would have gone up, then we'll take plus 15 sine 10. But in this case, the ball is going down. So the height will have to consider negative, which will be minus 15 sine 10. So here I'll have to add a minus sign. So even one minus sign will be placed here. Even this will become minus. Now again putting this in the calculator. The answer I'm getting is 8.25. So the final answer, the velocity is 8.25 meter per second. Let's move to the second question. Coplanar forces of magnitude, this is this. Given that sine alpha is 15 by 3, theta is this, find the magnitude and direction. Okay, so now in this case, there are three forces acting on a same plane. And now what we have to find out is that what will be the resultant force of these three forces? What does resultant force mean? If I tell you that there is one force acting like this, let this be A, and there is one force acting like this, let this be B. So what will be the resultant force of A and B? What will be the resultant force of A and B? So what will you do is, you will simply make a line in the center like this, and this will be the resultant force. So similarly, we have to find the resultant force for this one, this two, and this 3, these three forces. So how do we find the resultant force? First of all, we'll have to resolve the forces. Now, what do I mean by resolve? How to do? I'll show you. Let's start. First, you have told us sine alpha is 15 by 3, 5 by 13. So alpha will be sine inverse of 5 by 13. And similarly, sine theta is 8 by 17. So theta will be sine inverse of 8 by 17. Now, if I put these in the calculator, the value for alpha of sine inverse of 5 upon 13 will be 22.62. So alpha is 22.62 degree. Let me write it here in a better way. Yeah, and theta will be 8 sine inverse of 8 upon 17, which is 28.07. So this is 28.07 degree. Now let's move forward and resolve these forces. So first, let's talk about the 34 Newton force, which is this force. So I can resolve this force in two planes. One will be this, and the other one will be this. Now I can bring this arrow up here, and it will become this. And this forms a 90-degree right angle triangle. Now let's make the diagram right here. Once again. This angle is 28.07. This is 34 Newton. Now let's find y and x. So according to trigonometry, this is the opposite side and this is the adjacent side, ADJ. So I can, one second. Yeah, adjacent side. So I can use sine 28.07 is equal to y upon 34, and I can use cos 28.07 is equal to x upon 34. Now this 34 will go up, which will become 34 sine 28.07, and this 34 will go up, which will become 34 cos 28.07, and this x, which is the upward arrow, is 34 cos 28.07. So let us rewrite it here. This will become 34 cos 28.07. And let me erase this. Now that we are done with this, what about the horizontal arrow? Not this much in length. The length should be this much only. Yep. So this is 34 34 sine 28.07, which is y. We found out y, which is this arrow. So 34 sine 28.07. Now that we are done with this, let's move to the 26 Newton arrow. So again, I'll make a diagram. One force will act to the left, one force will act downwards. So if I draw the diagram again, one force is acting downwards, one force is acting to the left, this is the main force, which is 26 Newton. And this is the angle, and the angle is 22.62 degree. This is 90 degree. Let us label this as y, this as x. So if I use trigonometry, sine x, this is the opposite side, this is the adjacent side. So sine x is equal to y upon 26. Similarly, cos, not x, sorry, sine 22.62. One second, let me write it properly. Sine 22.62 is equal to y upon 26, and cos 22.62 is equal to x upon 26. So this 26 will go up, which will give us 26 sine 22.62, and this will go up, which will give us 26 cos 22.62. So what is this x exactly? This x is the downward arrow. The downward arrow is 26 cos 22.62, and this is 26 sine 22.62. Let us rewrite it here. So if we draw the downward arrow properly, this downward arrow is 26 cos 22.62. 26 cos. And the arrow on the left, let us redraw it here. The arrow on the left will be y, and this is y, 26 sine 22.62. So this will be 26 sine 22.62. And now, what about 30 Newton? 30 Newton is already acting to the right, so there is no need to resolve this first. So let us now differentiate all the forces. So we found two types of forces here. The first one is vertical forces. The other ones are horizontal forces. So this 1 and 2 are vertical forces. The force acting upwards is 34 cos 28.07. And the force acting downwards is 26 cos 22.62. Now, two forces are acting on the left and one force is acting on the right. So the force on the right is 34 sine 28.07. Another force on the left is 26 sine 22.62. And the force on the right is 30 Newton. So now we have to find the magnitude and direction of the resultant of the three forces. So what we will do is we'll find the resultant vertical force. So if I put this in the calculator, the value for 34 cos 28.07 will be 34 cos 28.07 will be 30 Newton. And the value for 26 cos 22.62 will be 24 Newton. The value for 34 sine 28.07 will be 16 Newton. The value for 26 sine 22.62 will be 10 Newton. And the value for 30 is 30. So now, as you can see, this upward force is greater than the downward force. So we can write the resultant vertical force is 30 minus 24, which is 6 Newton upwards. So if I make another this here, the resultant is 6 Newton upwards, and the resultant for horizontal will be the resultant horizontal force is equal to, if we do force on the right minus forces on the left, the force on the right is 30, minus forces on the left are minus 16, minus 10. So which is 30 minus 26, which is 4 Newton. So that means we took right as positive and we got a positive answer. That means the direction will be right. So 4 Newton to the right. 4 Newton to the right. Now we know that the resultant force is 6 Newton up and 4 Newton to the right. So now we can find this resultant force using Pythagoras theorem. This 6 Newton, I will shift it here. And this line will be my resultant force, which is F resultant. So I can use F square, resultant square is equal to 6 square plus 4 square. Therefore, F resultant equals root of 36 plus 16, which is equal to root of 36 plus 16 is 2 root 13, which is equal to 7.2 Newton. And 7.2 Newton, this is the resultant force. Yeah, now we found the magnitude. Now we also need to find the direction. So direction will be this angle. Theta we can't use, alpha we can't use, we can use beta. This is angle beta. So we can use trigonometry. Tan beta is equal to, this is the opposite side, and this is the adjacent side. Because this is hypotenuse, this is the hypotenuse side. So tan beta is equal to opposite upon adjacent, which is 6 upon 4. Beta is tan inverse of 6 upon 4. If I put this in the calculator, the value for beta, which is the angle, I'll get a tan inverse of 6 upon 4, 56.3 degree. So the angle is 56.3 degree. Let's move to the third question. A ring. Okay. This is a relatively rare question. So make sure as you solve this, you also try to find a few more ring questions and solve it. So we'll start. A ring of mass 0.3 kg is threaded on a horizontal rough rod. Okay, let's start making the diagram right away. This is a rod. It is very important that you understand the question properly. Yeah, this is a horizontal rod. The coefficient of a ring of mass 0.3 kg is threaded. Now, what does this threaded mean? Threaded means nothing but the ring is right here. So think of this as a ring. So let me draw it here. The shaded region is what you can see. If you still don't understand what is drawn right here, I'll give you an example. 1 second. Yeah. So this is what it will look like. This circle is the ring, and this is the rod, rough rod. Because there is rough, we can understand that this will also include friction. This is the rough rod. Now, if you still don't get understand, just think of your hand. Your hand may have a finger ring, and you may also have a pencil, of course. So if on the pencil, you take out your finger ring and put your finger ring on this pencil like this, put it inside. So this is what the diagram is, nothing else, nothing complicated. So in short, what this threaded means is this. Surprisingly, there is no need for a thread, even though the question includes threaded. So make sure you understand this and let's move forward. Yes, see the coefficient of friction. That's what I predicted here. Between the ring and the rod is 0.8. So the coefficient of friction is 0.8. A force of magnitude 8 Newton acts along the ring. Okay. So, but at what direction? This force acts at an angle of 10 degree above the horizontal in the vertical plane containing the rod. Okay. So this 10 Newton acts at an angle of 10 degree. So this, let us start from right here. This will act at an angle of 10 degree. How? Such that this is 10 degree, right? Okay. Find the time taken for the ring to move from rest. Okay, important point. That means initial velocity is 0 meter per second. Let me write it right here. This is called micro, and this is called simply u. This is coefficient of friction, and this is the initial velocity. So make sure you don't confuse between the two, and make sure you understand both of them. Find the time taken for the ring to move. Okay, time we have to find out. So because there is a force of 8 Newton that is acting along the ring, so there will be acceleration. Why am I saying this? Because force is equal to mass into acceleration. So if there will be force, there will also be acceleration. So now what we need to realize is this is not the only force that is acting. There will be one more force, which will be the resistance force, which I'll write as Fr. So now let's start. Oh, 0.6 meter along the road. So one more detail is distance is 0.6 meter. Now how do we start? First, we'll have to find out what the acceleration is. Then we can use the ut plus half at square or v square equals u square plus 2as or v equals ut equations. So in order to find the acceleration, I'll have to find a resultant force. Now what is the resultant force? The resultant force will be this force, which is the component of the 8 Newton force. Let us find out what it is. So first, let's make the two components for the 8 Newton force. So one is acting to the left, this one left, and one is acting up. So let's redraw the diagram here. This is 10 degree, this is 90, this is 8 Newton, this is X, this is Y. According to trigonometry, this is the opposite side, this is the adjacent side. So sine 10 is equal to X upon 8. X is 8 sine 10. So this force on the left will be 8 sine 10. Similarly, the force, no, my bad. This won't be 8 sine 10. What will be 8 sine 10? This X is the upward arrow. So 8 sine 10 will be the upward arrow. So let me draw the upward arrow here. I'm doing nothing but just shifting the arrow. And let me erase this ring and rough rod. So this upward arrow is 8 sine 10. And what about y? Cos 10 will be equal to y upon 8. So y will be equal to 8 cos 10. And y is the arrow to the left. So the arrow to the left will be 8 cos 10. Now let me erase this 8 Newton force, because now that we have resolved the force, that this means the same thing. such as if one 8 Newton force acts at 10-degree angle, I can instead write 8 sine 10 and 8 cos 10. Both of them mean the same thing because the end result will be the same. The object will move like this. Even in this case, the object will move like this. So now that I have resolved the forces, there is no need for me to write the 8 Newton force at 10-degree angle. Let's move ahead. Oh, yeah. So now what will be the resultant force? The resultant force will be 8 cos 10 minus Fr. Fr is the frictional force. Now what will be the frictional force? Fr, as we know, is coefficient of friction into R. We know the coefficient of friction is 0.8. So instead of coefficient of friction, we can write 0.8. Now what is this R? This R is nothing but the upward force here. This force is R. And how will this act? As you can see, the ring has a mass of 0.3 kg. So if mass is 0.3 kg, then weight will be 3 Newton. How? Weight equals mg. M is 0.3, g is 10. So weight is 3 Newton. So weight always acts downward. So this force is 3 Newton. So R will be equal to 3 Newton minus 8 sine 10. 3 minus 8 sine 10. So Fr will be equal to 0.8 bracket 3 minus 8 sine 10. So now we also know Fr. Let me rewrite it here. F resultant is equal to 8 cos 10 minus Fr. We know this equation. And in this Fr, in place of this Fr, I will write this 0.8, 3 minus 8 sine 10. Putting this entire thing in the calculator, 8 cos 10 minus 0.8, bracket 3 minus 8 sine 10. The answer is 6.59 Newton. So this is F resultant. We know F resultant is mass into acceleration. So 6.59 is 0.3 into acceleration by 0.3. The mass is 0.3. Therefore, the acceleration is 6.59 upon 0.3, which is 0.0.3, 21.97 Newton meters. 21.97 meter per second square. Now, we know the acceleration 21.97 meter per second square. We know the initial velocity is 0 meter per second. How? They have told us that it starts from rest. We know the distance traveled is 0.6 meter. What we don't know and what we have to find out is the time taken for the ring to move. So at this acceleration, how much time will the ring take to move a distance of 0.6 meter if it starts from rest and accelerates at 21.97 meter per second? So we can simply use S equals ut plus half a t square. Therefore, 21 point S is 0.6, u is 0, so this entire thing will become 0, plus half acceleration is 21.97 and t square. So this will go up, this will become 2 into 0.6. This will go down, this will become upon 21.97. And what is left is t square. So this square will go there and it will become root. Therefore, the value for t is root of 0.6 into 2 upon 21.97. So the time taken is 0.2 234 seconds. And that's how we are done with this question. Let's move to the next question. Oof, a particle, again a question about friction. A particle of mass 12 kg is on a rough stationary plane inclined at an angle of 25 degree. Let's start drawing. Twenty-five degree, 90 degree. Particle of mass 12 kg. So the mass is 12 kg. So weight equals mass into gravity. Mass is 12, gravity is 10. So weight will be 120 Newton. And weight always acts vertically downwards. This will be 120 Newton. Now that I have drawn this, let me also write the components due to the weight. One will act parallel to the slope. One will act perpendicular to the slope. This will be 120 sine 25. This will be 120 cos 25. This is the concept of mg sine theta and mg cos theta. So let me erase everything. Mg cos theta, mg sine theta. Yes. I may even erase this also. Acting at an angle of 25 degree to the horizontal, a pulling force of magnitude P Newton acts. So there are two possibilities, pushing force and pulling force. Now, how will we find out pulling and pushing? How will we find out the difference? Let's see in a while. A pulling force of magnitude P Newton acts at an angle of 8 degree above a line of greatest slope. Okay, so this is acting at 8 degree. So now there are two possible options here. The pulling force can be like this, or the pulling force can be like this. And this angle will be 8 degree, or this angle will be 8 degree. Either this can be P or this can be P. Which will be P, we will find out. This force is used to keep the particle in equilibrium. Okay. The coefficient of friction between the particle and the plane is 0.3. So let us write it. Coefficient of friction is 0.3. Now that means when a frictional force will act. So if P is acting downwards, if P is acting downwards, P is acting downwards, then frictional force will act upwards. Why? Because due to the weight, this is already moving downwards. And because P is acting here, that means two forces are acting down the slope. Because the component of this P will act down only. So in order to resist that movement, the frictional force will act upwards. But this is just one of the cases. What if P acts upwards? One second. Yeah, I've erased it all. This is left done. What if P acts upwards? Now, if P acts upwards, the component of P will act like this, right? So now there is one force down 120 sine 25, and there is one force to the right, which is P. Now P, this will be P cos 8. How will it be P? This will be P cos 8. How will it be? We'll find out later. Let's just go with it right now. So now F resultant can act both ways. If P cos 8 is greater than 120 sine 45, then it will act downwards. Why? Because if this is greater, that means the particle will start moving upwards. And it will, in order to resist it, resistance force will act moving downwards. But if 120 sine 25 is greater than P cos 8, then resistance force will move upwards. Why? Because if 120 sine 25 is greater, I'll repeat, if 120 sine 25 is greater, then the object will start moving downwards, and in order to resist that, resistance force will move upwards. So now we have two cases of this P. And out of this, one is completely ruled out. After I did this, find the greatest possible value of P. I completely ruled out one possibility, and that is this one. Why? Because in this scenario, both P is moving downwards and 120 sine 25 is moving downwards. So the only thing which will move upwards will be the frictional force Fr. Now let us make a tug of war diagram. So this is one person, this is the other person, this is the rope, this is the third person. So let this be P and 120 sine 25, and let this be Fr. So now they have told to find the greatest possible value of P. So now here there are two people, and here there is only one person. So P won't have much load, not much load. That means it will only have to apply minimum force. That means the application of force will be less. But what they want is the greatest possible value of P. So this is not possible. That means P can't move down. Because here P won't have its maximum value. The value of P will be less because it also has the support of 120 sine 25. Now, how can we maximize the value for P? Let us make another diagram. If we can do something such that P is the only one here, and it is balancing both 120 sine 25 and Fr. If it can balance both in this, then P will have the maximum value because P will have to do the most work here. And how is that possible? That is possible if 120 sine 25 and Fr act in the same direction. Now let me erase all of this. Now, how will 120 sine 25 and Fr can act in the same direction? How can we make this a case? This will, so this 120 sine 25's direction is fixed. Why? Why is 120 sine 25's direction? Because it is because of the force of the weight. So it will always act downwards. So Fr must also act downwards now because we want to maximize P. So this is Fr. Why do we want to maximize P? Because we have to find the greatest possible value of P. And hence, P will be the only force. I repeat, P will be the only force that will be moving upwards. But what they have told us is it acts at an angle of 8 degree. So P acts at 8 degree upwards. So now we have only one case left. Now let's solve this. But before solving, let us resolve this into two forces. So I've made the two arrows here. Let me redraw the diagram in a neat manner. So this looks something like this. This is P Newton. This is 8 degree. Let this be x, let this be y. We can use sine. Sine 8 equals x upon p. Cos 8 equals y upon p. This is adjacent side, ADJ. This is opposite side. Opposite side means x. So if there is opposite, we'll use sine. And if there is adjacent, we'll use cos. So p sine 8 is x, p cos 8 is y. I repeat, p sine 8 is x. And what is x? X is the upward moving arrow. So this is x, which is p sine 8. This is p cos 8. So let me redraw the diagram. P cos 8 is moving to the right. P cos 8 is moving to the right. Similarly, P sine 8 is moving upwards. So this I can just shift it here. Once again, not a proper arrow. Yeah, this will become P sine 8. Let me raise the mass. Yeah, we are done here. And now what we have to do is we just need to solve for forces. Because what we need to find out is the greatest possible value for P. Now that we have everything, we can find P. How will we find P? The first thing that if it may have slipped out of your mind, I'll remind you. It's that they have written here the particle is in equilibrium. If the particle is in equilibrium, the particle is in equilibrium, that means there will be no resultant forces, no resultant force. Hence, therefore, resultant force is equal to 0. And now what is this resultant force? This resultant force will be, let me minimize this. Resultant force will be, because this is trying to move in the direction of P cos 8, we'll consider P cos 8 as positive. P cos 8 minus 120 sine 25 minus FR. Now F resultant as we know is 0. So instead of F resultant here, I can just write 0. So now I'm going to do that. I'll just write 0 here. Yup. And now there are two unknown variables, P and FR. But let me tell you that we can find FR. How? Very easy process. FR is equal to UR. We know the value of U, which is 0.3. So instead of U here, I will simply write 0.3. Now how will we find R? And what is this R? This R is nothing but the contact force here. And what is R equal to? 120 cos 25 minus P sin 8. What is this R equal to? 120 cos 25, which is the downward force minus the upward force, P sin 8. Therefore, FR is equal to 0.3, 120 cos 25 minus P sin 8. Therefore, 0 equals P cos 8 minus 120 sin 25 minus, now instead of this FR, I'll write this entire thing. Minus 0.3, 120 cos 25 minus P sin 8. So now if I can just remove this bracket, it will become minus. So 0 equals P cos 8 minus 120 sin 25 minus 0.3 into 120 is 36 cos 25 minus 0.3 P sin 8. So this P and this P, will let it be here, and this will shift on the left side. So what we'll get is 120 sin 25 plus 36 cos 25 is equal to P cos 8 minus 0.3 P sin 8. Therefore, if I put this in the calculator, 120 sin 25 plus 36 cos 25, the answer is 83.34 is equal to P in bracket cos 8 minus 0.3 sin 8. Now I can put this down here. So 83.34 upon cos 8 minus 0.3 sin 8. Let me erase this. So therefore, if I put this in the calculator, the value, let me write it again, 83.34 upon cos 8 minus 0.3 sin 8. Therefore, the value of P is cos 8 minus 0.3 sin 8. Okay, so the maximum value of P possible is 87.9 Newton. 87.9 Newton. Let me check it here again. P cos 8 is mass is 12 20 cos 45. U is 0.3. Yes. P cos 8 minus 120 sin. Okay, so as you can see, this I multiplied this minus 0.3 and minus P sin 8 here. But what I forgot was a plus arrow. So this will be a plus. So your 120 sin 25, this we took it here, this we took it here, is equal to P cos 8. This will become a plus 0.3 P sin 8. So even this will become a plus 0.3 P sin 8. And this will become a plus. And if I put that in the calculator again, 83.34. The answer is 80.75. The answer is 80.75. Okay, so sorry for the little silly calculation error there. 80.75 Newton. Let's move to the next question. Fifth, a car of mass 1 to 5, 1250 kg is pulling a caravan of mass 800 kg. Let's start drawing a diagram. But is it a straight road? Yes. So let this be the car. Let this be the car one. Mass is 1250 and the mass is 800 kg. The resistance to the motion of the caravan 440 and 280 Newton. Okay. So on the car is 440. And the caravan is 280. Remember, these are the resistance force, not the driving force. 280. Wait a minute. Yeah. Now, the next is the car and the caravan are connected by right. Okay, already drew this. 1 second. The car and the caravan move along the horizontal part of the road. Okay, at a constant speed of 30 meters per second. So the constant speed of the car and the caravan will be 30 meters per second. Is there no driving force? Ah, that's what you have to calculate. Calculate the power developed by the engine of the car. So because there is power due to the engine, because there is power due to the engine, that means nothing but force driving. That means driving force. So because the engine exerts power, we get driving force, which moves the car. So which I'll draw here and I label it as FD. So this green arrow is FD, which is the driving force. Now what we have to find is the power. So now here what we can do is write power equals force into velocity. And what is power? Power of engine. And what is this force? Driving force into velocity. This velocity is 30. Okay, one more thing important here is that it is at constant speed. At constant speed, acceleration is 0. And because F equals ma, if acceleration is 0, then even resultant force, this is resultant force will be 0. So one more thing we found out is resultant force is 0. Now what we can write is resultant force will be equal to the driving force ahead minus the resistance forces. And because the resultant force is 0, 0 will be equal to Fd minus Fr. Therefore, 0 equals Fd. We don't know what is Fd. We have to find out. And resistance force is 440 and 280. Minus 440 plus 280. Therefore, driving force is equal to 440 plus 280, which is 720 Newton. Now, we can use your power equals force into velocity formula. Power of the engine we have to calculate. Driving force is 720, velocity is 30. Right here, constant speed of 30. 720 into 30 will be 21600 watt. Now, have they asked kilowatt or something? Yes, they have calculated in kilowatt. So 21.6 kilowatt, because one kilowatt is 1,000 watt. So 21600 watt will be how much? 21. My bad. 1 kilowatt is 1,000 watt. So how many kilowatts will be 21,600 watt? 21600, not 3 zeros, 2 zeros. 21600 upon 1,000. To cut, which will give us 21.6. Yes. Let's move to the next question. Given that this power is suddenly decreased by 8 kilowatt. Okay. So initial power. This power means power of engine. So initial power of engine is 21600 watt. Decreased power is 8,000 watt. That means this much power is decreased. In bracket, how much power decreased? And so the final power due to the engine, the final power will be 21600 minus 8,000 equals, so 21600 minus 8,000 is 13,600 watt. So this is the new power. Now, and realize that they have written decreased by 8 kilowatt, not decreased to 8 kilowatt is not written. It was written decreased to 8 kilowatt. That means the final power would be 8,000 watt or 8 kilowatt. But it is decreased by. So English really matters here. Find the instantaneous deceleration of the car and the caravan under tension in the tow bar. Okay. So let's label tension here. Tension will be inwards. This is the tension. Okay. So now we have the new power. Now what they have asked us to find is the instantaneous deceleration. That is technically negative acceleration. And instantaneously means velocity remains same. That means given that the car was traveling at a constant speed of 30 meter per second, will it now travel at the same speed? Yes. Why? Because instantaneously 8 kilowatt is being reduced. In So initially car is traveling here, car with a caravan, and it is traveling at 2160 watt. After reaching somewhere here, the power is decreased, but it will take some time for the velocity to decrease. However, because instantaneous deacceleration occurs, the acceleration will change. So let's go again to power of engine equals driving force into velocity. New power of engine is 13,600. Driving force is, we have to find out now. Velocity will be 30. Therefore, driving force equals 13,600 upon 30. Cut. Now, if put in the calculator, 1360 upon 3 is 453.33 Newton. Now, F resultant is equal to mass into acceleration. F resultant will be mass of the car and the caravan combined is 1250 plus 800. 1250 plus 800 into acceleration. Now, F resultant we also know is FD minus FR. So F resultant is 453. Oh, my bad. F resultant we have to find out. FD is 453.33. And FR will be 440 plus 820. 440 plus 820? No, 280. Now, if I put this in the calculator, F resultant will be minus 266.667 Newton. So now we can find the acceleration. F resultant is minus 266.667 Newton. If I input it in this, I have already put F resultant as minus 266 is equal to 1250 plus 800 will give me 2150 into A. Now this will go down, which will become upon 2150. So A is equal to minus 266.667 upon 2150. And so the answer is, if I put this in the calculator, so the acceleration is minus 0.125, which is, let me put that in the calculator again, minus 1.224 into 3.6 minus 8. Okay, so the acceleration is minus 0.124 meter per second square. Now we'll go ahead. What we have to find is the instantaneous deceleration. Deceleration means negative acceleration. So there is no need for this minus because we want to find the deceleration, not the acceleration. So the instantaneous deceleration is 0.124 meter per second square. This is the first answer we have, which is the instantaneous deceleration. And now we'll have to find the second, which is the 1 second. If I put minus 266.67 in the calculator, I did a calculation error here. If I'm putting this in the calculator, I'm getting 0.125 meter per second. And minus 0.125 is 0.13. Rounding off to 2 decimal places. So the final answer is 0.13 meter per second square. Okay, we'll move ahead. Now we have to find the tension in the tow bar. How do we find the tension in the tow bar? Now let's only take one caravan. We can even do it with a car, but let's do it with a caravan. Why? Because I want to. So this is the caravan. Mass is 800 kg. Resistance force is 280 Newton backwards. And the forward force is tension. No other force. Okay. So the resultant force for this caravan will be T minus 280. And if resultant is mass into acceleration, the mass of the caravan is 800 and the acceleration will be minus 0.125. Therefore, 800 into minus 0.125 is equal to T minus 280. So hence, finally, we can find T. And the answer for T will be, this 280 will go there, it will become plus 280. And if I put that in the calculator, 280 plus 800 bracket minus 0.125. So the answer for T is 180 Newton. Now we can even do this with the car. Let me do it with the car also. Just to show you the answers will be the same. Now doing it with the car, let me redraw the diagram. Car mass 1250 kg. Forward force is driving force. Driving force is 453.33 Newton. Backward force will be tension. And another force is the resistance force, which is 440 Newton. Is there any other force? Driving force done, 440 done, tension done. No other force. Okay, so the resultant force will be 453.33 minus T minus 440. And we also know F resultant is mass into acceleration. Mass is 1250. Acceleration is minus 0.125. Okay, so 1250 into minus 0.125 is equal to, if I put this in the calculator, 453.33333 minus 440. The answer is 13.333 minus T. Therefore, if I can put T here and this here, so T is equal to 1250 into 0.125. Notice that if this goes there, the minus sign will be removed because going to the other side, negative will become positive, plus 13.333. Now if we put this in the calculator, plus 13.333. If I put this in the calculator, the answer for T I'll get is 1250 into 0.125. Answer plus 13.3333. So the answer I got is 180 Newton. The value for T is 180 Newton. Hmm, 280. Here, what we found out was 1360 upon 3. Now, if I put this in the calculator, 1360 upon 3, 1360 upon 3 is 45.33333. This is going till infinity. So we'll let it be as 1360 upon 3. Now, instead of 45.33 here, we'll use 1360 upon 3. So 1360 upon 3 minus 440 plus 280 will give me minus 800 upon 3. So let us write minus 800 upon 3 here. And so here also we'll use minus 800 upon 3. Minus 800 upon 3, answer upon 2150. So will give me minus 16 upon 219. So this will be minus 16 upon 129. Not 219, 129. And here also instead of this we wrote as 0.13. So this should be minus 16 upon 129. So let me write this as minus 16 upon 129. So if I write 800 into minus 16 upon 129 plus 280. So the answer for tension I'm getting is 175.5. So I hope you recognize the error. The error was I rounded off it in between the question. You can't round it off. We have to write it in the simplified form, in the fractional form. If there is some answer with ending 3.33333, which is for example 11 upon 3 is 9 za. So it will be 3.66667. This 66 goes till infinity. So we can't just write it like this. We will have to take 11 upon 3 everywhere as our simplified version. So even here, instead of minus 0.125, I will have to take minus 16 upon 129. So if I take minus 16 upon 129, and if I do it again, minus 16 upon 129, answer minus 113.333. Yeah, so the answer is 175.5 Newton. No. So now, finally, what we understood is here they had told us to find the instantaneous deceleration. So what was the instantaneous deceleration? This was the instantaneous deceleration minus 800 upon 3. So which converted to, was this the instantaneous deceleration A equals minus 266 upon? The instantaneous deceleration was minus 800 upon 3 upon 2150. So which give us minus 16 upon 129, which is minus 0.13. Now let me write the last point in the black pen. This is minus 0.13. So because this is the answer here, this is the answer because they have asked us to find the instantaneous deceleration. We can use this in the integer form. So we can take this as minus 0.13 here. Even here, we can take this as minus 0.13. So here also we'll get minus 0.13. Now if you put it in the calculator, you will get 175.5 Newton. Mean 175.5 Newton. Now what you need to realize is there are two rules for this. First one is do not round up, round off in between the solving. What does that mean? That as you are solving this, solving, and for example, you get FD as 1360 upon 3. So 1360 upon 3 cannot be further simplified. But have they asked it as an answer here to find the driving force, new driving force? No, they have not. So what you have to do is we have to use one FD as 1360 upon 3 as that's it, as how it is. So FD anywhere if I use, for example, here, I can't use 453.333, which is the simplified version of FD because this 33333 is never ending. But I can't use it. I should only use 1360 upon 3. Now, coming next, the second rule is use integers or fractions. Use integers for not integers use numbers for further solving if answer is asked. Now, what does this mean? Acceleration was asked here, instantaneous deceleration. So we found it out here, which was minus 16 upon 129. But now, because this answer was asked, so then we have to write it in the whole number form, minus 0.13. And we even have to use the same minus 0.13 in questions. Why? Because they have asked for the answer. Now you can write this in your important points. You can make two differentiations. One is the answer asked, answer not asked. And asked will be whole number. This will be fraction. Whole number and decimal also. Decimal is fine. For example, minus 0.13 decimal. So now that you are clear with this new rule right here, let's go ahead. I know this may sound weird, but as you can see here on the first page itself, they have mentioned here, give non-exact numerical answers correct to three significant or one decimal place for angles in degrees, unless a different level of accuracy is specified in the question. So answers we have to give in three significant figures or one decimal place for angles or unless specified, because this driving force FD was not specified in the question. We have to use the most accurate, the fractional form, which is 1360.3. Now enough of this mess. Let's go to the next question. The car and the caravan now travel along a part of the road inclined at sine inverse of 0.06 to the horizontal. Car and car travel up at the incline at a constant speed. Engine of the car working at this, find this constant speed. Now, one thing you need to remember is resistance force remains the same. Because they have not mentioned the road is smooth or road is rough, and new value of micro is not given. They have not mentioned all of this. That means we have to go with the same thing which is given in the previous question. Now, what does previous question mean? The previous question does not mean you have to take it from here or here, because this is part A. This is second part. This is a completely new question B. Because it is written here in the general text, which is not part of any question, we can take it for 40 and 280. So let's start making the diagram. Sine inverse of 0.06. So if I put that in the calculator, sine inverse of 0.06 is 3.4398. 3.4398 degree. But now that we have found out, we can't use this because it is not an answer. So we just write sine inverse of 0.06 degree. Now going forward, the car and the caravan travel up the incline. So the car and the caravan are traveling up. So motion is upwards at a constant speed. Okay. So here we discussed constant speed means acceleration is zero. Acceleration is zero, then resultant force is zero. If acceleration is zero, hence resultant force is zero. So we know the resultant force is zero here. Working at 28 kilowatt. Okay, so no, new value of power is 28,000 watt. Find the constant speed. Okay. So, but before that, let us label the masses and everything. This will be the tension. What is the mass? The masses are 1250800. 1250 and another due to gravity, Newton. 8,000 Newton. Yes. And now the forces due to the weight will be 12500 sine inverse of 0.06. Now what happened here? We know the component of weight is mg sine theta. What is m? 1250 for the car. What is g? 10. And sine, what is theta? Theta is sine inverse of 0.06. This entire thing. So again, sine inside sine inverse of 0.06. Now moving to the next one. For the caravan, it will be 8,000 sine inverse of 0.06. Okay. And what about the resistance forces? The resistance 440 on car, 280 on caravan. 440 on car, 280 on caravan. Anything else here? Yes, power of engine. That will lead to, let me use another color. That will lead to the driving force on the car. So we have to find the constant speed. Now, how do we find the constant speed? First of all, we know that resultant force is zero. We also know the resultant force will be equal to the driving force minus 12500 sine inverse of. Now, if I put in the calculator, sine inverse of 0.06 will be nothing but 0.06. Similarly, or also sine 0.06, this will be nothing but 0.06. So I can erase this entire thing. And I can write 0.06. And even here, I'll write 2500 0.06. Yeah, this will just save me space. Hope you realized how. If you put it in your calculator, sine inverse of any number x, the answer will be x. Try it in your calculator. Add 37 here, 45, 90, whatever the number, the answer will be the same. So if minus 12500 0.06 minus 8,000 0.06 minus 280 minus 440. That is the all the forces on the free body diagram. F resultant is 0, so 0 equals, so instead of F resultant I can write 0 here. So 0 is equal to, now if I add everything here, so minus 12500 into 0.06 minus 8,000 into 0.06 minus 280 minus 440. The answer I'll get is minus 1950. So the driving force is 1950 Newton. Now we know power equals force into velocity, power of engine and driving force. So power of engine is 28,000 watt. So 28,000 watt. If you are confused about how this power of engine and driving force came, then listen to this explanation again of the first question. You'll understand how power of engine and driving force came here. Why not resultant force or something else? 1950 into velocity. Therefore, velocity is equal to 2800 28000 upon 1950. So the answer will be B is equal to 28,000 upon 1950, which is 14.36. So the velocity is 14.36 meter per second. Now let's move, because we have read that the answer should be in three significant figures unless specified. We write as 14.4 meter per second. The final answer is 14.4. Find the increase in potential energy of the caravan in 1 minute. Okay. So we know that the car will travel at a constant velocity of 14.4 meter per second. Now, in 1 minute, there are 60 seconds. Distance is equal to velocity into time, which will be 14.4 into 60. So the answer will be 14.4 into 60, which is 864 meter. So that means in 1 minute, the car will be traveling 864 meter upward. Now we also know that the angle is sine inverse of 0.06. So what will be the height h? Therefore, we can use trigonometry. Sine inverse of 0.06 is equal to height upon 864. Now 864 will go there. So 864 is equal to sine this is this. Now as we discussed, sine of sine inverse will become the same thing. So 864 into 0.06 is equal to h. Therefore height is equal to, if you don't know the explanation, 1 second. If you don't know the explanation, then see the video for the question for B1. You will get it. Because even sine inverse of this was used here and we converted it to 0.06 directly. How? Watch the video for B1 again. So 864 into 0.06 is 51.84 meter. That means the height is 51.84 meter. But are we done here? No, we are not. Why? Because we have to find the increase in potential energy, which is the increase in GP. What is the GP? GP is mgh. So because you have to find the increase in GP, what we'll have to write here is the increase in height. But we can't just add arrows here. So you'll have to write delta. Delta means change in height. So mass of the caravan. Okay. So what will be the mass of the caravan? Mass of the caravan is I guess 800. Yeah. Caravan of 800 kg. So mass of the caravan is 800. Acceleration due to gravity is 10. Increase in height is 51.84. So GP is 8,000 into 51.84. And so this will be a huge answer of 414,720 joules. Yeah, and we are done here. We can also convert it to kilojoules by dividing it to 1000. So 414,720 upon 1000. So 1, 2, 3 here. Joule 414.72 kilojoule. We are done. Let's move to the sixth question. Oh, the sixth question is a 8-mark question. So I can't say the question will be difficult, but I can surely say the question will be tricky, which will be prone to a lot of silly errors. So in case you have tried this question and you have not got it and you have come here, make sure to watch this explanation very carefully, very carefully. And in case if you're just watching this explanation without trying the question, I will first suggest you anyways don't do this mistake of just watching the video directly before even trying. The first thing you should do is try the paper on your own. Try the paper on your own. In case if you are not getting any question, then you should watch the video explanation. Or you are thinking if you got the answer, you're not confident, then you should watch the question. But first, you must invest your own time and thought on the question, then watch the video. That's what will be helpful. Now, moving to the sixth question, let's start reading. A particle A, I guess there will be 2 pages given for this. 8 mark question, 1 page won't be enough. Oh, see, there are 2 pages. Yeah, this comes from experience. Don't worry. Once you solve a lot of papers, you will get it too. A particle A is projected vertically upwards. Let's start drawing the diagram. I'm very much interested in drawing this diagram. I'll reduce the size one more bit. Yeah, this is perfect. 1 second. Yeah. This is particle A projected vertically upwards. What speed? Projected vertically upwards. Let me label it A. With the initial speed of 30 meters per second. At the same instant, particle B is released from rest 15 meter vertically above it. Okay. So particle B will be somewhere here. It is dropped from rest. One second. Let me draw this again. This is dropped from rest. The mass of one of the particles is twice as the mass of the other. Oh, so that means 1 second. Very important and very confusing for many of you right now. Mass of this if is x kg, then if mass of B is x, then the mass of A will be 2x. Or if the mass of B is 2x, if the mass of B is 2x, then the mass of A will be x. The mass of one of the particles is twice as the mass of the other particle. Now, what we have to use, we have to consider both. We don't have to consider, we have to exclude one, we have to make a case. What we have to exactly do, we will find out now after reading the question. During the subsequent motion, A and B collide and coalesce to form a particle C. Okay. At the same instant, particle B is released from 15 meter vertically above A. Oh, so what happens here is, here we have two particles A and B. One person, he will throw A at 30 throw upwards, A upwards at 30 meter per second. At the same time, at the same instant, some other person or the same person where it may be, by 15 meter above the ground, 15 meter, some other person will drop the ball. Drop means first he might has it in his hand or something. Initially the ball is at rest. Because of gravity, it will come down and it will gain velocity. And this is happening at a distance of 50 meter. And A and B are completely below each other. That means they will collide. Oh, okay. So this is kinematics and momentum combined. And they coalesce to form a particle C. Okay. Find the difference between the two possible times. Oh, so we have to use both of these. Now, what is going to happen is, first let's understand this much. This ball is dropped. Now first let's find out at what time do they meet and at what height do they meet. So first the distance covered by A and the distance covered by B, not distance, displacement actually, will be equal to 15, correct? If A travels this much, then B will travel this much and both will equal 15. If B travels this much, then A will travel this much and both will equal 15 because both are dropped at the same height. Somewhere they have to meet, but the distance traveled by both will be 15. Now, what is displacement of A? We can use S equals ut plus half at square. So now I will take this question very, I'll explain this question very slowly so that you can understand each part of it. So displacement of A will be 30t because initial velocity is 30 plus half. Now let me tell you one thumb rule that is not only for this question but for the entire of kinematics. That the thumb rule is, if something is moving downwards, it is considered negative. If something is moving upwards, it is considered positive. So now, here what you have to realize is that displacement, velocity, acceleration, all are vector quantities. What is vector quantities? Vector quantities means they have direction. Now, many of you who are new may think that A, this is A here. So A in this case will be gravity, which I will take -10. Why? Because gravity always acts downwards. This will act at 10 meter per second square. Gravity G. So hence I'm taking it as negative -10 meter per second square. Why? Because of this thumb rule. Negative will be, no, downside will be negative. And t square will remain t square. So we are done with SA. Now let's talk about SV. So displacement of B, again we can use S equals ut plus half at square. U will be 0. So this entire thing will become 0. Half at square will again become half into -10 because even here gravity is moving downwards. -10 meter per second square. So -10 t square is equal to 15. Therefore 30t, this will become -5. -5 t square, then this will become -5. -5 t square is equal to 15. And therefore what we need to realize here is, your in case of A, the displacement of ball is upwards. S is upwards. Hence, we are taking this as negative, which is the acceleration is negative. Because there is something moving upwards, we are taking this as positive and this as negative. But here, the displacement of the object is negative, minus. The displacement is negative, right? Why is the displacement negative? Because upwards is positive, so S will become minus. And the gravity is also negative. So what we can do is, we can take this as positive because minus minus will convert to positive. So if the ball is moving downwards, its displacement will be negative. So in gravity will be negative. So if both are negative, we can consider it as positive. So this will become phi t square plus. Therefore, this phi t square cancel out and t will become 0.5 seconds. Why? Because if this cancels out, what remains is 30, t equals 15. Therefore, t equals 15 upon 30. So t is 0.5 second. That means as at the instant both of A has started to move upwards and B downwards, after 0.5 seconds, they will collide. They will touch. I hope that much is clear with you. So now going ahead, we'll calculate at what height are they touching. At what height. So now what we can do is, we can again write displacement of A equals 30t minus phi t square. What we got here, 30t minus phi t square. And we can put t as 0.5 seconds. Therefore, displacement of A is equal to 30 into 0.5 minus 5 into 0.5 the whole square. And if I put this in the calculator, the displacement of A which I'll get is 30 into 0.5 minus 0.5 into minus 5 into 0.5 the whole square, 13.75 meter. That means A has traveled up 13.75 meter. So let me draw the diagram again. In short, this is the initially first diagram. Then what happens is, after 0.5 seconds, A moves up 13.75 meter. So 13.75 will be somewhere here. A moves here. And so this remaining part will be 1.25 meter. B will come here. B, A. And they will meet here after 0.5 seconds. That is what we find out. Now, what they have told us is, during the subsequent motion, A and B collide and coalesce. Coalesce is nothing but stick. Stick and become one to form particle C. So, what will happen is, at the same instant, here if I put on, this will be 13.75, this will be 1.25, and at here somewhere, A and B combine, merge to form C. So this becomes one entire block, C. So this is what happens. Now what will happen is, find the difference between the two possible times at which C hits the ground. So when C, it will move somewhere now, probably up, probably down. That we'll have to find out. And it will touch the ground. So the time taken from here, t equals 0, to here, my bad, t equals t. How much time will it take? That we have to find out. So how will we do that now? We'll do it with the help of momentum. And how with the help of momentum? Let's see. So now there are two cases here. We know the two cases. Either this is x kilogram, and this will become 2x kilogram. If this is 2x kilogram, then this will be x kilogram. So now let's solve for both cases individually. Let me draw a line here. The first case will be A is x kilogram. If A is x kilogram, so B will be 2x kilogram. And they both meet, they both meet where? At 15.75. Now there are some things which are constant for this question. What things are constant? Irrespective of the mass, both will meet at this point. Irrespective of mass, both will meet at this point, and it will happen after 0.5 seconds. This is constant. So now keeping that in mind, that what is constant? Collision happens at t equals 0.5 seconds above 13.75 meter. My bad. Collision happens at 0.25 seconds, 30.75 meter above the ground. This is the constant scenario. So now I won't even make this diagram. Let me just make this. This is 13.75. What is happening? Yeah, 13.75, 1.25, B, A. Your mass of A will be x kg. Mass of A will be 2x kg. Same here, but only one difference. 13.75 meter, 1.25 meter. B will be x kg and A will be 2x kg. So we are considering here A was x, here A is 2x. So now let's solve for both. What will we solve? We will solve initial momentum equals final momentum for this. Now what do I mean by that? Initially what will happen is that when A reaches here, A will have some velocity, upward velocity, and even when B is moving down, B will B will have some downward velocity. That will be the initial momentum of A and B. So the initial momentum of A and the initial momentum of B, that will equal the final momentum. That will be when they stick together and become one particle. That is the final momentum of C. That means after this happens, they will stick together at this point only at 13.75, 1.25, and right here it forms C. So what will be the momentum? That we will find out. So initial momentum of A will be mass of A into velocity of A. So what is the mass of A in this case? The mass of A is x. So x into velocity of A. So as A reaches 13.75, what will be its velocity? That now we will have to calculate. How? We can use v square equals u square plus 2as. We don't know the final velocity as it reaches 13.75. We have to find out. Initial velocity of A was 30. So 30 square plus 2. Acceleration will be negative minus, and u square will be positive because it is moving upwards and upwards is positive. Gravity will be negative minus 10 and display S is 13.75. So v square will become v root, which is equal to root of 30 square plus 2 bracket minus 10 into 13.75. Putting this in the calculator, I got 25 meter per second. So this is 25 plus initial momentum of B will be mass of B into velocity of B. So what is the mass of B? The mass of B is 2x kg in this case, into what is the velocity of B now? What is the velocity of B? We can use V equals U plus AT. Even in this case, we could have used V equals U plus AT. But it does not matter. We are getting the answer anyways. The velocity we don't know. Initial velocity of B is 0. Acceleration is plus 10. Now, even the acceleration due to gravity here is plus 10, minus because it is acting downwards. But because the ball is also moving downwards, as we have discussed in the previous sub question, hence we will take it as positive. In case if the ball is moving upwards and gravity acts downwards, then we'll take gravity as negative. But if the ball is moving downwards, so we'll take this as positive only because both are happening in the same direction. Going ahead, acceleration is plus 10, time is 0.5. We know that the collision occurs at 0.5 seconds. That means 0.5 seconds they'll reach here. So the velocity is 5 meter per second. We can just check if we are getting the same answer of v ut with this. So v equals u plus at. The initial velocity of A was 30 meter per second upwards. Therefore, v equals 30. Acceleration will be minus here because velocity we considered upside, minus 10. Time is 0.5. So 30 minus 10 into 0.5 is 5, which is 25, which is the same answer. Hence our working tail now is correct. This is a good method to prove our answers. In case if some answer was different here, then we should have been alert that there is some mistake in our working. So V is 5 meter per second. That means velocity of B will be 5 meter per second. But now what you need to realize is 5 meter per second will be downwards velocity of B because B is moving down. So if B starts from here, earlier it is 0 meter per second. As B comes a little down as it moves as it reaches here, it will become 5 meter per second. But downward is negative. So here we'll have to consider a minus sign. Why here minus? Because we have already considered, one second. We have already considered 25 positive here. M into 25. So here technically we have taken plus 25, right? So, and 25 was moving upwards. So what about this 5? This 5 is moving downwards. So we'll take minus 5. 2x into minus 5. Let me rewrite it properly. So now we are done with this. Final mass of C will be mass of C into velocity of C. So mass of C will be x plus 2x, which is the sum of the masses of AB. And velocity of C, that's what we have to find out. Because from that only we'll find out how much time will it take for C to come down and reach here. So now let me erase this. I'll write it again because it may give us marks. V equals u plus at. So velocity of A equals initial velocity of A plus acceleration of A into t. Velocity of A was, um, we don't know, we have to find out. Initial velocity of A was 30 plus A is minus 10 to time. Time was 0.5, which gave us 25 meter per second. Using another pen, velocity of B equals initial velocity of B plus A of B into t. So velocity of B is 0 plus. Now, check this out. If acceleration of B, we earlier took plus because both were in the same direction. But if we take this as minus and this as 0.5, so automatically we'll get the answer as minus 5 meter per second, which we took here. Why did we get minus? Because B is moving down, right? B is moving down. So if we are taking gravity as minus, we'll have to think of this. We'll get the answer of minus 5 meter per second. But if we are taking gravity as positive, we'll just get the answer 5. But now we'll have, after that, we'll have to apply our logic that because B is moving downwards, we'll get the answer minus 5. So it is better you take minus 10 only so that there are no chances of error. So now that we are done with this, x plus 2x into c, okay. Now, let me simplify this. You will find something shocking now. X into 25 is 25x. 2x, 2 5s are 10, but minus 5 is there, so minus 10x is equal to x plus 2x will be 3x into velocity of c. 25 minus 10 will be 15x equals 3x into velocity of c. If you have not seen it till now, this 3x will go down upon 3x, x and x will cancel out. Yes, x and x cancels out. And surprisingly, from two variables, we'll get the answer for for only one variable, which is velocity of c. And velocity of c, which will become 13/5 is 5, become 5 meter per second. So velocity of c is 5 meter per second. But this is one condition where b is 2 kg and b is 2x and a is x. And because we have got a positive answer, that means the direction of c will be up or down? Correct, up. Because up is positive, down is negative. Up is positive. So upside will be 5 meter per second. Now we can calculate the time it takes for the particle C. It will go up 5 meter per second. That means it will reach some height. And again, it will come down, down, and it will reach this point. So how much time will it take? That we have to find out now. And how will you find that out? Now, first thing you have to remember is the object will travel down. That means its final displacement will be from here to here. That means displacement will be negative. And how much? It will be 13.75 meter. But we know S equals ut plus half at square. And what will S be? S will be 13.75, correct? Wrong. S will be minus 13.75. Why? Because displacement, it is traveling downwards. It started from here, from 13.75, and it reached 0. So total displacement travel will be minus 13.75 because it is going down. So after, now that it has fixed your mind, fit in your mind, the initial velocity of this C is 5 meter per second t plus half. Acceleration due to gravity will be negative minus t square. This will become minus 5. Therefore, minus 5t square plus 5t plus 13.75 is equal to 0. This went there. Minus 5t square plus 5t, and this went there, which became plus 13.75. Now if I put this in my calculator, how can I put this in the calculator? In case you don't know, I'll show you. You can press mod 5 and 3 then minus 5, 5, and 13.75. I guess I'll get two answers. One of the answer is 2.23 and the other answer is 1.23, minus 1.23. But can time be negative? No. So we'll exclude this. We'll just take the answer as 2.23. Time is 2.23. Why did it not take minus 1.23? Why did we not take minus 1.23? Because time cannot be negative. So that means once the object starts moving from this point, C, from 13.75 meter, it will take 2.23 meter to come down. But if you recall, this will be only this much. This is 2.23 seconds. But we have to calculate the entire time from here to here. So what will we do? This took how much seconds? This took 0.5 seconds. So first 0.5 seconds for both touching and then 2.23 seconds for this to reach down here. So we'll do 0.5 plus 2.23. So therefore, total time is 0.5 plus 2.23. Therefore, time is 2.83 seconds. No, 2.73 seconds. This we have solved the first case where the mass of A will be only x kg and mass of B will be 2x kg. Now let's move to the second case where 1.25 meter and 3 and A is 2x. So again we will go initial momentum is equal to final momentum. You'll have to write IM, FM both. Either you can write total momentum before equals total momentum after, or initial momentum equals final momentum. You'll have to write it in entire words in your exam paper. I'm just writing like this only here. So initial momentum of A plus initial momentum of B is equal to final momentum of C. Same case here, even C will form. So now mass of A into the velocity of A plus mass of B into velocity of B is equal to the final momentum, which is mass of T C into velocity of C. So now mass of A is 2x. Now here, when we found out the velocity for A and B, did it anywhere include mass? No, here it is only initial velocity, final velocity, acceleration, time. That means if the mass was either x kg, 2x kg, 1 kg, 2 kg, 10 kg, 20 kg, 50 kg, 100 kg, these answers will remain constant. Hence, the velocity of A will be 25. Mass of B in this case is x kg. And velocity of B, again, here irrespective of mass, if a 100 kilo object and a 1 kilogram object both are thrown from a height 15 meter above the ground, after reaching 1.25 meter down, both will have the same velocity, which is minus 5 meter per second. We can either say 5 meter per second down the ground or below or downwards, or we can say minus 5. But here again, we took 25 here and 25 was upwards. This 25 is upwards, 25. So the down arrow, this we'll have to consider negative. Since we'll again write minus 5. Mass of C is again 2x plus x. Is x plus 2x. Velocity of C we have to find out. Now you may think everything we have written the same, we'll get the same answer. No. Why? 2x into, what is 2x into 25? 2x into 25 is 50x. What is x into minus 5? Minus 5x. 2x plus x is 3x into velocity of c. Now 50 minus 5 is 45. 45x. 3 will go down is equal to velocity of c. X cancels out, c becomes 15. Because this x and 2x were interchanged. This became 2x here, x became 2x because the masses were interchanged, right? That's why we did not get the same answer. So in this case, the velocity of c will be 15 meter per second. Now, if these both merge at this point exactly, a and b merge, and this c travels upwards at 15 meter per second. So again, the distance it has to travel is downwards minus 13.75. So we'll consider this as the initial velocity, and we'll again go with s equals ut plus half a t square. So s is minus 13.75. U in this case is 15. Time we have to find out. That's half into minus 10 t square. Therefore, minus 13.75 equals 15t minus 5t square. Therefore, 0 is equal to minus 5t square plus 15t plus 13.75. Now, if I put this in the calculator, again mode phi 3 minus 5, 15 and 13.75. The answer is 3.73, 3.736 or minus. Again, the answer cannot be negative. So only one possible option, 3.736. Okay. So T is 3.736 seconds. Now, what is this 3.736? That is just the time it will take from here to down. T equals 3.736. But what about the A and B meeting together? When A and B met together, that also might have taken some time. We've already found that that is 0.5 seconds. We have already found that that is 0.5 seconds. So the total time it takes for it to meet is 0.5 plus 3. For it to reach the ground from initial time is 0, it will be 0.5, 1 second, 0.5 plus 3.736, which is 4.236 seconds. Now let's go to the final question. Find the difference between the two possible time. Very easy. We know one time, we know second time. Difference will be, therefore answer is, difference means subtraction, 4.236 minus 2.73. So 4.236 minus 2.73 will give us 1.5. And therefore, our final answer is 1.51. Actually, I got 1.506, which converts to 1.51 seconds. Therefore, the difference in time is 1.51 second. No, 4.236. Let me, I guess I have done error here. If I put it in my calculator here again, if I put this minus 5, 5t, minus 5 plus 5 and 13.75, then I will get 2.232. Okay. So here it should be 2.232 seconds. So here 2.232. So 2.732. So here minus 2.732. Again, if I put this in my calculator, 4.236 minus 2.732. 1.504. Okay. So 1.504. That is 1.50 seconds. Because the answer should be in three significant figures. So one thing there are two things to learn from this. Obviously, you have to understand the concept that is by default in any question. But two special things what you learn from this is any question, if you think hard, if you understand, if you make diagrams from the starting itself, whatever I do, that is my favorite thing to do, to be honest. Whenever I first read the question, I make a diagram. Because once you understand the question and make a diagram, your chances of silly errors reduce to 75%. You won't do silly errors three times out of four. One time you may do because you are inexperienced, you may not know how to solve it, you did some calculation, calci error. But other than that, if you make a diagram, silly errors will be way down. So that is one thing. And the second thing is, after doing this much also, so people can lose mark, even a single mark here, even though I will get full mark for this working. I did one silly error here, 2.32. I did not write this 2, and I would have lost a mark. So make sure we already discussed this in the which question? In the 4B question already. No, not 4B. We discussed it in the 4A2 question. 5A2 question, that why we can't take normal whole number values in between. For example, if FD is 1360.3, we can't take 453.33333. We'll have to use 1360.3. Similarly, here also we have to use the whole number here. We have to use the whole number, 2.232 and the entire thing. So if I would have done this, I would have got 1.51 and my 1 mark would have been reduced. So make sure you don't do such errors here. But this working looks so beautiful. This entire thing is just for one question, which is for 8 marks. Oh my God. It is even difficult to read in one side. Yeah. Now without further ado, let's go to the next question. The last question of the paper. A particle P moving in a straight line starts from rest at a point O. Comes to rest 16 seconds later. Okay, that means initial velocity is 0. When time equals 16, then also the velocity is 0. At time t seconds, leaving acceleration. Okay, oh. So three acceleration time graphs are given. And what they have told, there is no sudden change in velocity. Fine. Find the values of t. Okay. So first, let's make a diagram for the acceleration time graph. Acceleration time. At 0, what will be the acceleration? A equals 6 plus 40. When t is 0, this entire thing becomes 0. So at t equals 0, A is 6. So this will start from here. And at 2, 6 plus 4 2s are 4 2s are 8, 8 plus 6, 14. 14. That means in 2 seconds, the graph will reach here. Okay, what next? 14. So for next 2 seconds between 2 to 4, A remains constant at 14. And then 4 to 16, 16 minus 2t. So at 4, 16 minus 2, 2 4 is 16 minus 8 equals 8. So acceleration will suddenly change at 4 and it will become 8. 16 minus 2, 2 4 is 8, 8, 16. So 8 will be somewhere here. And at 16, 16 minus 2 into 16, 16 minus 32, which is minus 16. So that means at 16, acceleration will be minus 16. So drawing a graph minus 16 here. So this is how a graph will look like. Okay, but 14, 16 minus 2, 8. Okay. Now let's go ahead. Find the values of t when the velocity of p is 55 meter per second. Okay. So now we have to find the velocity. Now if we have a acceleration time graph and we want to find the velocity time graph, what do? We integrate. In order to integrate, let's first integrate this. A dt is equal to 6 plus 40 dt, which will give us the velocity time graph, which is 60 plus 40 square upon 2, which is 2t. Therefore, the first is 60 plus 2t square. Now moving to the next one, integral of a dt is equal to integral of 14 dt, which is equal to v, which is equal to 14t. So the next one is 14t. Moving to the next one, integral of a dt is integral of 16 minus 2t equals v, which is equal to 16t minus 2t square upon 2. 2 cuts to 1, which gives us 16t minus t square. So now let's draw the velocity time graphs. So the velocity will be 60 plus 2t square for time 0 to 2. Velocity will be 14t for time 2 to 4. And the velocity will be 16t minus t square for time 4 to 16. Okay. So now that we have this, you have to find the values of t when velocity of p is 55. So, oh, we did not mention one thing here. That was plus c, plus c, plus c. So here, and each values of c will be different. Let this be c1, c2, and c3. So this will be plus c1, plus c2, plus c3. Because whenever we do integration, we have to include c. Now, how will we find these values of c? And this c1 is very easy. Why? Because they have told the line starts from rest at point O. That means initially when it starts moving, it will be at rest. And what is this c? This c is nothing but the y-intercept. If we have a graph, in this velocity time graph, when will it touch 0? It will touch because it starts from rest at point O. That means at time t equals 0, the velocity will be 0. So initially it is at 0 comma 0, which is the origin point O. So the c will be 0 here. So c1 is 0. We figured that out. Now, what about the velocity at 2 seconds? So the velocity at 2 seconds, if we find from here, that will be 6 bracket 2 comma 2, 2 square, which is 6 2s are 12 plus 8, which is 20 seconds. So now we can input this 20 seconds here. So 20 is equal to 14t plus c2. Now, what about this t? This t obviously will be 2 because we want to find the velocity at 2 because that is the c intercept here. So therefore, c2 will be 20 minus 28, which is minus 8. So c2 is minus 8. Now next, we'll find the velocity at t equals 4. At t equals 4, v equals 14, 4 minus 8. If I put that in my calculator, 14 into 4 minus 8 will give me 48. Now inputting 48 here, 48 is equal to 16 t minus t square plus c cube. Now instead of t, we'll input 4 obviously because we want to find the intercept. So 16t will become 16 into 4 and minus t square will become 4 square. For 48 minus 16 into 4 plus 4 square is equal to C3. And therefore the answer for C3 is 48 minus 16 into 4 plus 4 square, which is 0. So C3 is 0. And now what we have found out is the y-intercept for everything. So the y-intercept for A is 0. That means C1 is 0. For the second one, 2 to 4 is minus 8 and even C3 is 0. So now that we are clear with everything, let's find out that when does the speed reach minus 8? When does the speed reach 55? So how will we do that now? So we'll put 55 in place of all of the v's here. So first will be 55 equals 60 minus plus 2t square. Therefore 0 equals 60 plus, 1 second. Let me rearrange this equation because this will form a quadratic. So 2t square plus 60. This I just reversed, nothing else. 55 will go there to become minus 55. And if I pull out my calculator, mod 5, 3, 2, 6 minus 55. The answer I'll get is 3.95 and minus 6.95. So t is 3.95 and minus 6.95. But the range of t here is only 0 to 2. So that means that after that, this we'll consider between 2 to 4. And this 3.95 lies between this, but that is not the equation we will use. So hence, it will not reach 55 between time 0 to 2. So we are done with this. There is no use of this. Now second part. 55 is equal to 14t minus 8. So 8 will go there. 55 plus 8 will become 63 upon 14 equals t upon 14 is t. Therefore, the value for time is 63 upon 14, which is 4.5. So, but here the range is 2 to 4. Not helpful at all because 4.5 is in the range of here and the equation is something else. So let's move to the next third part. 55 is equal to 16t minus t square. 55 is equal to 16t minus t square. Therefore, 0 is equal to minus t square plus 16t minus 55. Putting that in my calculator, minus t square will become minus 1, 16t will become 16, minus 55. The answer is 11 and 5. Okay, so time is 11 and 5. What fits in the range? The answer we got was 11 and 5. 11 perfectly fits in the range between 4 to 16. And when 5 fits in the range, okay, perfect. So the times and the values of t at which velocity is 55 will be at t equals 5 seconds and 11 seconds. So the answer is 11 seconds and t equals 11 seconds and t equals 5 seconds. And that's our answer. Let's go to the B question. Complete the sketch of the velocity time graph diagram. No problem, can be very easily done. I'll rewrite these equations again. V equals 60 plus 2t square. V equals 60 plus 2t square. This is for time 0 to 2, right? Yeah. Next is V equals 14t minus 8. Two to 4. And next is V equals, I'll copy it from here only, minus t square plus 16t. Let me check it. Minus t square plus 16t. Perfect. So 4 to 16. Now let's buck up and get back to work. Complete the sketch. So now you may have already realized 2 to 4 is given. That means this straight line is given. Now we have to do for 60 minus plus 2t square and this. So at 0, what will be the time? Let's find out. V equals 6 into 0 plus 2 into 0. That means velocity will start from 0. Anyways, we knew this. How? Here it was written. What was written? Starts from rest. That means initially at starts from rest at point O. That means at the origin starts from rest 0. We just proved it here, nothing else, nothing so overwhelming. And at time 2 seconds, what will happen? V equals 6 bracket 2 plus 2 to the whole square, which is 6 2s are 12, 2 8 20. So that means at 2 it will reach 20. Now, will the graph be like this or will the graph be like this? This is the major question to ask here. Now, what I want to tell you is understand. In a quadratic equation, if there are two possibilities, what is a quadratic equation? The quadratic equation is ax square plus bx plus c. If a is negative and a is positive, that will only depend, this will only change how the graph looks like. So if a is negative and if a is positive, how do the graphs change? I will show you. See, if a is negative, then the graph will look sad like this. And if a is positive, then the graph will look happy like this. That is what you need to remember. And what is the proof for this? You put this in the calculator. Go to Desmos, a website, Desmos. Do you want me to do it for you? Yeah, let's do it. 1 second. How will I do it though? Control or Shift H. I will have to change a few settings. New share I will have to do. I don't know how to do this actually, but let's see. Okay, so first I'll have to open Desmos. So you'll have to wait for a while. 1 second. No, instead of Desmos, I can use my regular calculator also, which is available on the Windows website. This may be a little time consuming, but if you see this complete explanation, then in any other question like this where you have to find the graph and other time a quadratic will come, you will without hesitation, you will get the answer, whether the curve will be a upward curve or the downward curve. Okay, so I opened this. Let me share this now, new share. Yeah, calculator also. So I hope I'm sharing my calculator now. This is my graphing calculator. So let me write ax square, 1 second, ax square plus 3x here. And right now you can see a is 1. See, if a is 0, that means only 3x will be remaining. So this is a straight line. As a turns positive, this becomes happy. As a is turning negative, it is becoming sad. See, a is minus 0.1, it became sad. A is plus 0.1, it became happy. If I increase, it still remains a V. And it here negative, it becomes a opposite V, inverse V. I remember it as if it is negative, then it is sad, then positive, then plus. Now let me change this for you. Let me make it minus 3x. Will it make any difference? No. Negative, sad, positive, happy. Let me add some constant, plus 7. No change. Only A can make the difference. If A is negative, then it will be sad. If A is positive, then it will be it will. If A is positive, then it will be happy. If A is negative, then it will be sad. So let me now share my Edge again, Microsoft Edge and calculator. Yes. So we now know that B and C do not affect the curve at all. The only thing affecting what the curve will look like is just the negative and positive. If A is positive, then it will look like this. In this case, A is positive. And what is A? A is the value which is to the left of the square. So x square. So what is to the left of this square? T square. It is plus 2. So if A is positive, then it will look happy. It should look something like this. So happy means it will look something like this right here. Because if you continue this, then it will look like this. And that's what we want. So now that we are clear with this, let us now we have the let me make a better curve so the examiner can see I have actually made a curve. Yeah. And 4 to 16. Now even this is a quadratic. Oh, see, this is a sad one. Minus t square. So A is negative. So what will we do? We first will find out at 16 what is the velocity. They have the term that it comes to rest. The line starts from rest at point O and comes to rest 16 seconds later. That means the velocity at time 16 will be 0. And now that we know that when the time is 16 seconds, the velocity comes to 0, we can also say that this point right here is somewhere what we have to touch. But now, can we just make the diagram like this? Or does it have to be something like this, or what exactly? So for that, we need to find the highest point of the graph, of this graph. Which graph? Um, t minus t square plus 16t. And that we'll find using derivative. We'll have to find the highest velocity point, something, and the time at which the highest velocity point occurs. So now let's start finding that. So technically what we have to find right now is the, one second, I'll erase this. Technically what we have to find right now is the minimum or maximum point, not minimum point, maximum point. So in order to find a maximum point of the graph, what we have to do is you have to derivate the equation. That is what we do in basic mathematics, derivation. So we know that v equals minus t square plus 16t. So if we derivate this equation, we will get minus 2t plus 16. Now gradient of the graph at maximum point is 0. So we'll equate this with 0 plus 16. Therefore, minus 16 upon minus 2 equals t. And the value of t is 8. That means this happens somewhere here at time 8. And now let's see the velocity. What is the velocity at 8 seconds? So v equals minus t square plus 16. Therefore, v equals minus t square is 8 square plus 16. Therefore, v equals plus 16t. Okay, so 16 into 8. So minus 64 and 16 8 if I put it in the calculator, 16 8 is 128. So therefore, velocity 128 minus 64 will be 64 itself. So velocity is 64 meter per second. So here let's label 64, and that will happen when time is 8 seconds. Velocity will be 64, and that is the maximum point of the graph. So the graph will look something like this. It has to be a sad face. So that this will be the sad face. Let me erase this orange line. Yeah. Yeah. This is our graph right here. And hence we have completed the sketch of the velocity time diagram. Now let's move to the C question. I won't erase this. I'll write it here only. Find find the distance traveled by P when it is decelerating. Now, what you need to understand is that we have a velocity time graph. And what is deceleration? Deceleration is nothing but negative acceleration. So negative acceleration, and how from a velocity time graph, the acceleration can be found out using the gradient. So the gradient, for example, at this point, the gradient will be this line. And this line, the gradient of this line will be something positive, and therefore the acceleration will also be positive. If we go here, here also the tangent will be like this, and the gradient of this line will be positive. And so the acceleration will also be positive. Now, as we reach at the maximum point, the gradient becomes a straight line. Here, the gradient is zero. The line becomes a straight line. The gradient is zero, and so acceleration is zero. Now, as we move here at this point or this point or this point somewhere, we can see a line like this. That means that the gradient is in negative. And so the acceleration will also be in negative. That's what we found out. That means after this point, 1 second, after this point, as gradient becomes less than zero, which is gradient becomes negative, acceleration will also become negative because this is a velocity time graph, and gradient of this graph will be um, gradient of this graph will be a, because this is a velocity time graph, the gradient of this graph will be the acceleration. So from 8 to 16 is our limit. Limit means, if you don't know what is limits, I'll tell you. Find the distance traveled by P. Now, what is the equation for time 8 to 16? This B equals minus T square plus 16 T. B equals minus T square plus 16 T. Now, in order to find the displacement, we have to integrate the velocity time graph, which will be integrating minus T square plus 16 T. Now, here the limits will be 16 seconds to 8 seconds. 16 seconds to 8 seconds dt. Therefore, displacement is minus t square will become minus t cube upon 3 plus 16t square upon 2 and bracket 16 and 8. Now, if I put this in my calculator, minus t cube minus t cube upon 3 plus 16 t square upon 2. So if I solve for 16, I'll get 2048 upon 3 minus, and now if I put 8 minus 1024 upon 3. So the displacement will be 2048 minus 1024 upon 3. So the so the final answer is 1024 upon 3. Now what have they asked? To find the distance traveled. So this we can in short write 341.33 meter. And that's how we end this question, and also we end this paper. Thank you for watching.